So here's let's take off the rust and talk about rationals. Here is the most simple rational of them all. Please write this down, y equals 1 over x. Why is it even called a rational? Because rational numbers can be written as a fraction. Hallelujah, somebody remembered the word rational. Rationals can be written as a fraction. So that's like the most simple fraction function that there is. Now, if you wanted to make a sketch of the graph, would you please take a second and just do you remember what these even look like? The research shows that if I let you try to sketch it, that it'll stick better when I tell you. Do you know how they look? Who remembered that it looks like that? Raise your hand if you did. Oh, about half of you, a little more than half. And that's because it's not touching these lines, which are called, something starts with an A. What do you think? Asymptotes. Good. There's two kinds of asymptotes. What and what? Horizontal and vertical. Good. And obviously the horizontal ones are like the horizon. So that's this one. And it's really easy to think, oh, it's the x-axis, so it's x equals 0. No, it's y equals 0 for the horizontal. Everybody label this. Like, write all of that out. Because I bet you some of you would have thought that was x equals 0. It's a really easy mistake to me.
I just memorized the alphabet.
That works. I just memorize it by going horizontal. There's a y in front of horizontal. All right. So then the other one's vertical, and that's going to be a zertical. X equals thing. And that's x equals 0. Now, could those move? Sure, we could move them. But now, from looking at the graph, it wasn't hard to see where the horizontals and the verticals were. But when you have a complicated one, like, for instance, x plus 3 over x minus 7, honestly, right off the bat, I don't know what that looks like. Because I just don't know. It is not, if there had just been a 1 on the top, I could say, oh yeah, that's been moved 7 to the right. But because it doesn't have just a 1 on top, it has an x plus 3 on top, I don't know what that's going to look like. So let's talk, I forgot already, what did I have there? Plus 3, thank you. Okay, let's talk about how you can find the horizontal and verticals from just looking at this. So everybody write this problem down, put HA and VA. And some of you guys, it'll come back to you. You'll be like, oh yeah, this is the kind where you put in the thing, and then the verticals come from this part. And rack your brain for this. See if you remember where the horizontals and the verticals come from. I'll pause for a second. Let me give that a try. Okay, you racked your brain. Some of you probably came up with something. Some of you didn't. I want to see what a random kid said. This is row 3, person 2. Liam, that's you. Do you remember either the horizontal or the vertical?
Horizontal asymptote is 1.
Aha! Do you remember the technique? You are correct, by the way, so now you can tell me, what technique did you use to get that?
Plug in 1,000, 1,000.
Ah, this is the one put in 1,000 thing. The idea is, if we went way to the right for x, if x was like 1,000, we'd be way over there. We'd see if it leveled off. And when you do put in 1,000, then 1,000 plus 3 or 1,000 minus 7 are pretty much just 1,000 over 1,000, which is y equals 1. Raise your hand if you also had that before he said it. Okay, good. You've got decent memories. This is a good sign. How about verticals? Do you remember the vertical?
3 over 7.
Good try, but it does not involve the 3. Here's why. Verticals are only about the bottom, and so it's just the 7. So x equals 7. I know you had a partner that you talked with, so maybe you guys both thought that, or one of you convinced the other. But how many of you actually had x equals 7? Raise your hand if you did. Okay, good. All right. Now, I know I'm not going to say who, but I think there's at least one kid that is off doing something else. Go back to us. You need to be with us on this. All right. Y equals x squared minus 4. I think that might do something special. The next one is x squared minus 2x, minus 3x, no, wait. minus x minus 2. There we go. Now, this one obviously looks much more complicated, but I'd still submit that you could figure out the horizontals and the verticals, but don't forget the first step. What do you do first? If you can, factor it, you should. All right, Dice of Destiny, who should I call on? Row 6, well, there's only one of you. All right, Brady.
Well, so you got factor first, so for the top I got x plus 2 and x minus 2.
Correct, keep going.
And then for the bottom I got x minus 2 and x plus 1.
You are correct, sir. And then, did you notice something?
Yeah, there's a hole.
Very good, you even remember the name of it. This thing that cancels creates what's called a hole. All right, and then let's write down the simplified answer. Y equals, what's left?
X plus 2 over x plus 1.
Nice. Now, there's a hole. Different person explain that. Keenan, that's you. What is this hole thing he's talking about? Okay, so there's a hole somewhere. Some point is a hole. What's the x of that point?
2.
2, because 2 is the magic number that makes the top and the bottom 0. And then, how do you figure out the y of the hole? New kid. It came up to you again. That's not fair. I'm going to go with Becca Rowan. Into what equation?
Y equals x plus 2 over x plus 1.
That one, you're right. If I stick 2 into this one, it'll be 0 over 0. Okay, so that's why we have to put it in this one. So when I put 2 in there, final answer? 4/3. That's where the hole will be. All right. Dice of Destiny, who should I call on? Catherine Von Smith. Tell me what the horizontal was.
It is 1.
Why? You do the 1,000 trick. I'm going to put 1,000 here. And 1,000 here. Talk me through it now. Why is it 1?
Just don't understand it.
Okay. All right. Well, then that's good. We found something I can explain to you. Would you agree that adding 2 to 1,000 doesn't do very much? So we're going to just act like we didn't. And adding 1 to 1,000 doesn't do very much. So we just act like we didn't. So it's pretty much 1,000 over 1,000. And 1,000 over 1,000 is 1. So y equals 1. That's why. That's where it goes in the long run. When x goes way to the right, when you put in 1,000, it's like you're going way to the right on the graph, like way over there. Then you're seeing, oh, I guess it levels off at 1. That's why there's an asymptote right there at 1. Okay, and the vertical. Row 3, person 3, and that is Brooke.
Is it -1?
And why do you think it's -1? I'm not saying you're wrong, I'm just asking.
It's what makes the bottom 0.
It's what makes the bottom 0, yes. X equals -1. Now, what if you had to graph them? And yes, you will have to graph them on your test, which is coming. I'm not certain yet whether it's going to be Friday or if it's going to be Monday, but for sure, we're going to be having a test, and it's going to involve graphing these things. So would everybody please put the asymptotes on the graph and an empty spot where the hole is. So it's like a dot, except it's empty. And then you'll need to find me a few more spots. And my coaching was always go around the X asymptote. I know this has been a while since you've done this with me, but I always said put the whole -1 made, not the whole, sorry, the asymptote. That should go on your XY chart to inform you that you should put something on both sides of the asymptote. Do you have your y equals 1 right there? That's y equals 1. Do you have your x equals -1? Right there. Do you have the whole at 2 comma 4/3, which is above 1? Empty spot right there for this whole. Leah, can you tell me some number that I should put in on either side of the asymptote? -2 is one of the numbers. You are correct because it's right by -1. What's the other x number, just to get it in there? 0 is correct. So everybody stick in a 0 and a -2. That way you're getting something on each side of the asymptote. This is such a good way to do it that one of my colleagues who had watched one of my videos said, I noticed you did that. I'm going to do that next year. Because instead of just picking random points, it helps you know for sure 2 numbers that'll work really well because they're on either side of the asymptote. And I didn't think of this. Some other person taught me that that's a good way to do it. All right, so if you put in 0 into which equation? Always use the simplified one. I'm going to rewrite it here. It's y equals x plus 2 over x plus 1 after everything canceled. In fact, I'm going to put it back over here. When I stick in 0, oh, it works really nice. I get 2 over 1, which is 2. 0 comma 2. And when I stick in -2, I get, is that like a fail that I got a 0 on the top? No, what is 0 divided by anything? 0. So that's 0. I guess technically 0 divided by 0 would be a problem, but that's not what we have. So, okay, so there's my 2 key points. 0 comma 2, that's like right here. And -2 comma 0, and that's like right there. And from just that, you're supposed to be smart enough to know asymptotic behavior, meaning how things always behave around the asymptotes, which is to go closer and closer to them, will drive your line closer and closer to the asymptotes in both directions. And there's your final graph, and it would have been counted as good enough. I don't need 1,000,000 points. One pro tip for you, though, if you're like, I just still don't see where the graph should be, Mr. Servo, then get more dots. Try putting in -3 and see what you get. Get another dot, and then all of a sudden you'll get like something here. And then once you get like this many dots, you'll be like, well, duh. I can tell where it is because there's so many dots, it's obvious. So if you're ever struggling, just find more points. Okay, there's a review of almost everything. And here's the rest that makes it everything. What if I give you a graph and it looked like that? Can you tell that's the 1 over x graph, except moved? Then what if it also had a hole in it? Exactly right here. There was in the hole in the graph right above the number 5. This dotted line here, let's say that it is going through at 3. And let's say that this dotted line at the top that's going across that horizontal asymptote, let's say that it's at 2. Now you have enough info that you could tell me this equation. Now, I know this is hard, but some of you are going to pull it off. What's the equation for that? I'm going to pause for a minute, give you a chance to try it yourself. Hint, start with 1 over x. Adjust from there.
1,000.
Okay, let's talk it through. Would you agree? I said to start with 1 over x and adjust from there. So at least you have to have that in your answer. Does that make sense? Okay. Next, would you agree it's been moved to the right? How far to the right has it been moved? Just say it. You can do this. 3 spots to the right. See this asymptote here? It would have been at 0, but it's been moved 3 to the right. That means there's a minus 3 in it. Okay. Next, would you agree it has been moved up 2? All right. And how do I do up 2? That moves the whole thing up 2. How many of you had those elements all in your answer? Nice work. I'm not saying we're done yet, but that's so far. You get how the whole thing was moved right 3 and up 2? All right. Oh, question first.
Couldn't you just like add an x up there, which would then be double?
Can you just throw an x up on the top? No, you can't. Now, I'll show you at the end. We're going to do that to get a whole. But no, you can't just put an x on the top. Our base function is 1 over x, not x over x. You get the difference there? Our base function is 1 over x. If you just put an x on the top, you've totally changed what kind of function we had. All right. But now, at the ending, it seems like you think you know. What do you think?
I was confused.
Oh, question. Okay.
Because how I did it.
It's fine.
No, I was just wondering, so how would you get the vertical asymptote then if it's supposed to be 2 for the vertical asymptote, right?
All right, so let's talk about that. So the vertical asymptote is what makes the bottom 0. So process that with me for a second.
Oh, okay, yeah, never mind.
What makes the bottom 0? You tell me. What makes the bottom 0?
3.
So that's why we wanted the vertical asymptote at 3. I'm glad you're asking, so this is good. Any other clarifying, like why is it this way? I'll be happy to explain more. This is the hardest part, no doubt. Okay, then the last piece is the whole. Would you agree that the whole usually is something that cancels on the top and the bottom? And what number did we want to cancel on the top and the bottom? Well, the whole is right above the 5, so we wanted a 5 to cancel. So we can't put it out here. Actually, we might even be able to, but I've never done it that way. So what we should do is put it in here, because I know this works. And what do we want to put in there? We'd want to put, say it if you know it, x minus 5 and x minus 5. And then I better put parentheses around this to just kind of clean it up. Do you get how that would make the x minus 5s cancel and it would make a whole at 5? Now, at least now that you're seeing what the right answer was, do you understand how that could work? Does that make sense to you? All right. So let's see if you really understood that, because I'm going to give you another one. It's going to be in a different spot, of course, with a hole in a different spot. And let's see if you can pull it off. So this one's going to have asymptotes here, which is at negative 3, and here, which is at positive 1, and it's going to be here and here, like most of them are, with a hole right there at 2. Can you tell me the equation for that? Again, always start with y equals 1 over x and adjust from there. Okay, so here is the final answer. You should have known that this thing was shifted to the left 3. Did you know there was a plus 3 right there? Raise your hand if you did. Okay, good. Then it is also shifted up 1 because of this 1 right there. This is 1 above where it used to be, so that's a plus 1 outside of it. That moves the whole thing up 1. Are you right so far? Okay, good. And then there's a hole at 2, and so I need to put it in parentheses. X minus 2, and down here, x minus 2, and then I need to really put that in parentheses. If that was the only thing missing, I'd probably give you 5% off instead of all wrong. But you do need those parentheses there, because otherwise, just your 3 is getting multiplied in. All right, and this 1 does become optional because 1 times anything is not really there, so you didn't technically need the 1 on the top. Who had that exact answer? Cool. Now, don't be fooled by the straight line. This is the last kind. If it's just a straight line with an empty spot in it, you're going to think that that's like all of a sudden really hard. It's not. A straight line with the empty spot in it just goes like this. Would you agree that this equation, if it goes through the number, let's say that that's going through 3 right there, that this equation would have been y equals x plus 3. Assume for a second it has a slope of 1. Do you get that that's the line, y equals x plus 3? But it's got a hole in it. See if you can finish it from there. Don't overthink this. Just put the hole in and you'll have it. All right, let's see how you did on this. I hope you knew that this had to become a fraction function with something on the top and something on the bottom, and this had to be an x minus 5 and an x minus 5, and then last little thing, what's the last little thing? Somebody will know. This written the way it is going to lose 5%. Parentheses there. Because otherwise that 3 was the only thing that was going to multiply in. Do you get now the x minus 5s would cancel and make a hole at 5? Does this make sense to you? And then the left thing that's left after this does cancel is the line y equals x plus 3, which is this line right there. And I know my slope wasn't perfect. I'm aware my slope was probably not steep enough to be a slope of 1, but thanks for being patient with me. All right, so there's your review of everything. Now, we might just have one more review day tomorrow and then the test. And I have to talk to my colleagues, see what they're doing. I'm not sure, but I know this much. I'm going to give you a subset of the worksheet that is in today's folder. That's way too big for one night. Okay, so I'd like to just give you the evens on that. So everybody open up that worksheet and find number 2. If it's weird, like problem 1 has part A, B, C, D, E, F, G, then I gotta adjust this. But my goal is to give you like half of the problems.
You ready for day 7?
Whatever's in today's folder, just open that worksheet. Yes, I'm hoping for the evens, but again, if it's weird, like,
Yeah, it's missing
Gajillion
the graph
parts.
for 10.
but at least it's problems 1. It is numbered normally. It's not A, B, C, D, E, F, G. So this will work. Let's do the evens. And I agree that number 10, it seems to be missing a actual graph. But you know what? If you're skipping number 9, it'll be really easy to just put it there. You know what I mean? There's a grid right there. So, okay, so let's do evens. Would you please read me number 2?
X squared plus 2x minus 3 over x minus 1.
Can you double check that I copied it right?
Yep.
Okay, good. Then I bet you have to factor it. Dice of Destiny. Row 1, last person. Von Smith, the dice like you today. I'm not making this up. So what does the top factor to?
The top, it factors to parentheses x plus 3, parentheses x minus 1.
You are correct. Nice job. On the bottom, we have an x minus 1. Coincidence? I think not. That's going to cancel, and it makes a what? A hole. Always put a parentheses and a comma to remind yourself you can't just say that the hole is at 1. It's at 1 comma something. I like to rewrite my answer at the end. Y equals x plus 3. That's one of those straight line ones. You know, y equals x plus 3, that's a straight line that goes through y-intercept of 3 with a slope of 1. You can't afford to just forget algebra. And it's got a hole at 1 comma, well, I'm putting the 1 in, and it's 1 comma what? 4. So can you graph this? I hope so. Worst case scenario, you can always make an XY chart and find a bunch of dots and they'll all be in a straight line. And forget the hole. All right, you're doing the evens tonight. And it might be as simple as tomorrow, we just do some more review problems and you do the odds and then the test is the next day, but we will see. I'm curious, how many of you are terrified of the test being on Friday? All right, thank you for being honest. Only a few people seem to be terrified of it, or willing to share that they're terrified of that. I think that's the way we're gonna go, but I'm not positive. I will tell you for sure tomorrow, so you'll get at least 24 hours notice. And that's all I got for you for today.